Awesome. Yeah. I'm starting again. Welcome to the Hack workshop here. Let's take a quick look at our agenda for the rest of the 2 hours here. What we're going to do is a quick introduction for the Google team first. And then we'll talk about Google and HACC. And then I'm going to have my colleagues to deep dive into AI is a very popular topics today. I think our goal is really to help you to understand what AI is, understand all the tools that's available that's in there, so that you can use that either in the classroom settings or your own hobbies, or you can anticipate in the hack challenges using those skill sets you learn, and it can solve a lot of great problems here. And then we're gonna have hands-on labs. We'll go over some of those. The idea of which is that we'll spend the first 20 minutes, around 20 minutes, give you an overview of Google's AI. You may know some of those already. We'll just kind of level set things. And then we'll give you one hands-on lab. So the first 20 minutes really, we want to help you to become the AI expert in theory only. And then we're going to be hands-on on the keyboards. Those environment, we have 2 hours. Don't worry about if you will be able to finish the lab or not. Depends on your own pace. Then as a bonus, we'll give you another lab that you can take home if you have nothing to do this weekend and you will spare time to work on some of those, just give you a little more enhancement and understand what AI is. All right, so that is the agenda. Hopefully by the end of the day, we'll do some in the middle, this is a smaller classroom setting. So if you have any questions, feel free to jump in to ask this question here. So let me just go ahead and quickly introduce our Google team here. I have Jen Stanley, who's in the back. She's account manager, she managed everything, including this events here. She's a great resources, and if you need any resources, Google resources from technology perspective, we have run many workshops, including on the campus. We have done many projects together with the states and with the school here. So I'm Daniel Liu. I lead a custom engineer group. This is my team here, and we have also an extended team here. Personally, I've been covering Hawaii accounts for the last, I would say, almost 2 decades, making my trips here almost every month in the last almost decade and a half. A lot of mileage, a lot of times accumulate around here. But Hawaii is like my second home. I really love the places. I remember even when HACC happens, first year was back in 2016, right? And 2017, our team come to the island, where we sponsor the first events there. And it's been a wonderful experience since then. We almost anticipate there's a little break during COVID, but it was a great experience as we're involved, we're helping, we were in the workshops here. So we are here, our team here is really to help you to understand AI technology, to enable you with all the tools that you need, and to solve those big challenges that we have here, right? Whether it's on the campus, whether to solve problem for the states. I think the goal is even back to the previous governor, Ige was talking about, right? How can we maintain local talents on the island, right? There's so much opportunity on the island we can do together. So with that, I'm going to also introduce two of my colleagues here.
Hi, everyone. I'm Yasemin Hushmand, or Yasmin. I'm also a customer engineer reporting into Daniel. If you guys have questions throughout the workshop, feel free to reach out or just wave your hand. Myself and Sandeep and Daniel will come and help you.
Hi, good afternoon, good evening, team. I'm Sandeep Dogrikar, and I will be conducting session today. So thank you, Daniel, Yasmin, for all your help, Jen. Yeah, looking forward to our 2 hours together. So like Daniel said, first we'll go through some of the basics, demystify some of the concepts a little bit, and then let's do something hands-on.
Yeah, awesome.
All ready?
And I really hope that you guys all can anticipate in the hack this year.
Yep.
I might be the judge again this year.
So yeah.
So these are some great pictures we took together. We're gonna have some, we'll have booths over there on that judging day, and showcase of some of our technology and some Google swags that will be available for you. And but together we'll solve some great challenges together. Thank you.
Yeah. So I know it's a little late in the day. Anybody wants to stretch, get a little. So let's get started a bit. So firstly, why machine learning and why even now? So we are calling this as Industrial Revolution 4.0. If the first one was steam, second one was electricity, then IT. Given how even our CEOs and our industry peers are talking about it, we consider this to be a 4.0 revolution. Specifically within this, there is this generative AI, which is the new and exciting thing in machine learning. And this is impacting pretty much all of our industries here. This has allowed us to interact with machines like never before, right? And we'll see as we go through the session how you can, with few clicks, make your computer be almost human-like, right? The example we'll be talking today is ability to build a chatbot towards the end of this, where the chatbot can translate into 5 or 6 or how many other languages we want to, okay? And why now? So this again is very important because part of it is the technology. We have access to a lot of computing power now, which we didn't have then. So when I started my master's, you could draw a neural network 3 layers deep, and that's how the professor graded you, right? You had to hand draw weights, calculate it back. Now it's like billions of parameters. Everybody knows ChatGPT, Gemini. So yeah, so the technology is there to support it. We have a lot of clean data. Algorithms, most of them are old, right? But these are the two things that have changed: access to high quality data and computing power. So through the slides, I've created a few. By the way, this image and the joke both are created using Gemini. So what is AI's favorite snack? Microchips. Anyway, so just to keep it light, we don't take ourselves seriously here. So what is AI ML? So let's just level set on some of the basic concepts. At any point during the session, please feel free to interrupt me. Can have a conversation. AI is the big field. Machine learning is a subset of it. Deep learning is even smaller, right? So deep learning is, and even small, like generative AI is an even smaller subset of deep learning. This is what requires a lot of compute power. Let me play this video.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves.
Yeah, it's not enough crowd, right? 1 second, let me try it.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. but of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics.
Let's go to the next one. So this is an interesting game, and it builds on the concept we just discussed. If I click on it, it will open in a new tab. Won't see it. Let me stop sharing and share this tab instead. Okay, so this is where it's asking me to draw a pair in 20 seconds. So you see how it's trying to guess? There you go, right? It guessed in 11 seconds. Let me go back and share back the original slide. Share this tab instead. So the thing I wanted to call out by this example, and you can try it, this link works for you too, g.co quick draw. It gives you 20 seconds and you can draw a picture. It will ask you what to draw. But how do you think a program like this is working, right? So this is what is the magic or secret sauce behind it. It's the quick draw data. So over time, we have trained it on a lot of different, so this is an example of a carrot, different types of carrots that we have drawn over number of years with a lot of data. So it's, as soon as you draw a shape that is resembling of this, it goes and identifies that, hey, very likely a carrot. So this is where our traditional programming, which is a rules-based approach versus a machine learning, right? How they are different. So in the case of rules-based, when we write a program, right? It's pretty much, hey, if this is this much, right? It's a hierarchical way. We are giving it a set of rules. And if it follows a certain set of rules and the logic until the goals are met, right? Seems familiar, right? This is a rule-based approach of applying or programming. And this is the machine learning style, where instead of specifying rules, you give it data, and then it comes up with its magic to then say, hey, this is a carrot, right? So the output is almost like a program. In the prior case, where it was a rules-based approach, we were specifying the conditions and writing a program. Here, we give it data, and then the algorithm figures out what program it needs to apply. So this is like the basic difference between rules-based versus machine learning. Same thing, right, here. So if you had to use a rules-based approach to figure out that this is an image of a cat, you would apply, hey, if it is this tall, the ears are this shape, the tail is this long, right? Then it's a non-machine learning way of recognizing a cat. Whereas in the case of machine learning, you would have fed it a whole ton of images that are of cats, and then it would figure out the next time it sees a cat that, hey, this is more a cat. So there is a need for both approaches to exist. The rule-based one, it's not like machine learning is the answer for all problems. You use the rule-based approach because it's fast. You know exactly why it is making a certain answer. In the case of where it is not good is where you don't know the answer, or there may be too many rules, right? In the case of image classification, for example. The flip side is machine learning can do a lot of complex problems, but it requires a lot of data and is expensive. This is another example, machine learning generated, right? Or like I asked Gemini, why did AI get detention? Both this joke and, oh, what happened? Yeah. it got plagiarizing the internet. This is actually a real problem. Folks are getting caught for this. But even the cartoon image is generated. So firstly, I told the algorithm to, hey, give me a one-liner joke. It gave me this. And then I said, generate an image for the joke. Give me this. So let's get high level. What are the different types of machine learning? There are two big categories, and there is a third one, other, which is out of scope for today. High level, there is a supervised machine learning, where the model learns from labeled set of data. So you feed it images of cat and it's labeled as a cat. If you go back to the video, right? So you feed it a set of images and you tell the machine, it's a cat, it's a dog, it's a bird. The other way is unsupervised, where the model learns patterns autonomously. You are not specifying a label for it. That's the key difference. Supervised versus unsupervised. There are other approaches, human reinforcement, where you reward it based on whether it's making the right call or not. And then what are the applications, right? These are the three most common machine learning applications. First one is, we call it regression. This is where you're forecasting like a specific value, right? This example is for a house, right? A house has this many square feet, these many bedrooms, these many bathrooms. Based on that, and it's at this location, you are able to forecast what the selling price of a house would be, right? Typically, these types of algorithms are used to forecast continuous values. The other set of machine learning applications are classifications, right? You feed it a bunch of data and then you classify it, whether it's a cat or a dog in this case, right? And then the other one is clustering. You have a set of data. You want to visualize, okay, where do my data, like you want to analyze a set of customers, for example, right? Or you're running some business, you've got some feedback, you analyze. So this is where you're using clustering. You're finding patterns in the data. These are the three most common types of machine learning applications. An example of regression, where you're going from place A to place B. How long is it going to take? You can also incorporate traffic patterns. When are you leaving? Right? These are all inputs that will go into. This is quite literally in the case, right? In this case, it's lion, wildlife. You draw a line through this. These set of animals are one type, the other. Then this one is an example of clustering. 7 and 2s. 7s are here, 2s are there. There may be somebody who is, this 7 is very much like a 2, so it will come closer to this. And then lastly, which is today's topic, is generative, right? Where is the cat, right? You're predicting one word at a time, or you're generating a brand new image, or you're blurring an image. This is what we will be using today. Large language models, or LLMs. So what's different about this, right? So as the name suggests, right? These are large, 10 to hundreds of billions of parameters, right? So the latest one that Google has with Gemini is 1 million tokens of input, for example, right? The other thing that is different is it's trained on a large corpus of text, right? The volume of, or the data that goes into training these models is enormous. And then the last one is it can recognize, predict, and generate human languages. So these are the things that are unique, or what makes a large model large. These are some examples. Lambda, Palm, GPT-3, or Gemini. And then what makes them different, right? The biggest characteristic, I think, is it's emergent. What we mean by that is it's large enough where it's not trained to do a specific task. Sometimes the models are trained to, okay, find me fraud, right? Or do a very specific task, predict a house price. These ones are trained on such broad data that you can tune it or tweak it to accomplish your smaller tasks, right? So that's why we call them emergent. The other piece is it understands how contextual understanding of how human language is. And you will see it as you build the chat application today, where it knows that you're talking to it. It has the context. It's not like you just throw something and you got one answer and the conversation stopped. And then lastly, massive disparate data, right? It can find connections between them. So if you have an image of so when I gave it text, for example, right, I gave it a joke and I told it, okay, build a cartoon image from it. It was able to understand the joke and then build an image, right? So it knew it had some robot somewhere. So bring it all together and translate that. So that's what is unique about this, right? You have the ability to combine text, images, audio, video, and come up with something creative. Across the industry, these are like the 5 areas where we have seen generative AI get applied the most. The first one is the one we are most familiar with, which is creating, right? Whether it is you want to create an itinerary, hey, I'm going to Greece, give me 1 week itinerary for that. Or you want to create an image, right? Or you want to write a blog, format an email. All of these are in the create side of things. The second most popular that we've seen is summarizing, right? I have done this where Supreme Court hearings are on publicly available website. They are like 50, 60 minutes long. You can feed that audio and you can ask it to, hey, summarize this audio for me. And you can tell it, I want a 5 bullet point summary. I can do it for you. Discover is like searching. Whether you want to search through a document, search through even audio files, video files, you can search what you want, right? Imagine searching through a picture, right? Let's say you visited New York. You can ask a question, when was I in New York? And then it should be able to go through your pictures, find if there is a picture of New York, and then bring it up. These are sentiment analysis, automating some of the common tasks. I think chat is what we are building today, but we are using a combination of chat and create. And then there is a fun assignment, I think, is where you can build images. I hope all of you signed for Quick Labs. So you should have, there is a lab in there called Imaging where you can generate images. That's all I have, like, to set the basics. And this is what we are doing today is this concept of an AI agent. Forget these details in the boxes, but there is focus on what the agent does. It reasons how to best achieve a goal. You give it input, and then it has some tools at its disposal. We are not going to use this, but this is a simplified version of it, right? Today we'll be building an agent, and we'll asking it to do translation. In this case, it is booking a flight, but we will ask to translate. Okay. Everybody ready? Oh, that's behind you right there. Yes. It's on that, on the wall on your left too. Yeah. Yeah, 1 second. Stop sharing. And let me share my. Yeah, let's grab food. Yeah. Don't be shy. Yeah, let's grab a. Yeah. Sounds good. I'll leave the Wi-Fi and password on. All right, got some pizza.
Generated the image.
Did it? Okay, I did not know that. Detention of all the spellings to.
Go back to that.
Yeah. I'm curious. I did not pay attention to that. Yeah. NITION. Okay. Nice. Good catch.
Very illustrative that you didn't notice.
I did. Yeah, I did not
You know what I
actually.
mean? There's something about AI.
I focused on that plagiarism on that one. That's about it. Yeah, and this is right in my face. That word is larger.
For a project and
Mhm.
doing retrieval augmented generations to have a database.
Yeah.
My problem is many of the queries that provide these database calls.
Yeah.
It will fall in a lot of data. Answer the question, the next question, call through the same set of data.
Mhm.
And within 10 minutes, I think I was charged like $1 for the use of the AI agent. So I kind of like shut it down at that point, like.
So if it is the same set of data, we should be caching certain amount of it.
Right, so in the system of instructions, I told it,
Yeah.
these are pure functions, just for
Yes.
trying to figure
Yes,
out.
yes, yes.
Like, they're not gonna change, you can just cache the results.
You did tell it, and it still did not.
And it still was doing, you couldn't figure out how, so I actually lodged,
Did you lodge a bug or something?
well, it wasn't a bug, it was a feature request, like, how do
Okay.
I enable it to cache the results?
Yeah. Okay, I'll follow up. The challenge or the balance act here is as soon as like caching can be, then Google is starting to capture the data. We don't want that. We want to be forgotten, right? So that's the balance. So I'll follow up on that. That's a good. Yeah, I'll get it later. That's fine. Thank you. Is everybody connected to the internet, friends? Okay. Let me. So we had, I don't know, did everyone receive Jen's email to register for Quick Labs? Everyone register for Quick Labs here? Jen Stanley? Yeah, Quick Labs. Yeah, let's help you register for Quick Labs. Yeah, the word detention is incorrectly spelled here. Great catch. Are you able to open this website, explore.quicklabs.com? Yeah. Use the same email that you used to register, please. Yes. And I think in Quick Labs, you should find a whole lot many labs if it interests you. If you want machine learning, you can search for machine learning. Generative AI, you can find generative AI labs. It is free. There is no, it is just free. Yeah. Is there? Jen, isn't Quick Labs free, Jen? Yeah, Quick Labs or Cloud Skills Boost? Or was it Skills Boost? Skills Boost is free. I know for a fact that is free. Yeah. Yes. So there you go. You see this lab, right? Yeah. Yeah. Yeah, you should see agents in Vertex. No. You need to sign with the email that you registered. This one. Yes, okay, then give me your. Yes. Yeah, absolutely. Yes, tell me. Give me your email address. Yeah.
Ray.
You want to type it in?
Yeah,
Yeah, just type it in.
that is true.
Let me hold your laptop.
Oh,
You just type it in.
That's my email, yeah?
The one that you used to.
Yes.
Yep. Add student.
Okay. Thank you.
Oh,
okay.
Thanks. 1 second. I myself got signed out. 1 second. Type again, please.
Oh, okay.
Sorry. Yeah. Good.
Thank you.
Yeah. Go for it, please. Yeah. It's easier.
Do you mind if I go quick? Just email and search?
Yes,
Or...
just email and add.
Oh, up here.
Yeah,
Okay.
yeah. Right.
Thank you.
So once you enter the class, you should see this particular lab getting started with agents in Vertex AI Agent Builder. Everyone sees this? Awesome. Click on the first one, which says getting started with agents, please.
I should click the Start Lab button.
Yeah, we can start the lab. I don't think it will take us 1 hour, 30 minutes. It's but yeah,
Went through the guide in the past. This is all the first time.
first time for everyone, yeah.
So to just level set up some other things.
Yeah.
When you open the lab, you will actually get your own GCP environment. Google GCP as a GCP Google Cloud environment. And then one thing I'll probably do is there are 2 different ways you can do that because there are instructions there. Right?
Yeah, there is instruction. We'll go through them. We have to open in a incognito mode. All that. Yeah. Yes. Yeah. You want to go through that?
No.
Okay. Everyone on this side. Oh, what am I sharing? Let me share. So once you click on this open lab, right, you will see something like this. Are folks seeing the screen here? Very nice. So hit on Start Lab, and this should provision a cloud environment for you. Did I not click on it? Fresh. Start Lab. Yep. So this is our username, my username. Each one of you should have your own username, password, and a project. This is where we would be creating our very first generative AI agent. Everyone able to get here so far? Yay, nay? All good? Okay, let's. Okay, so this is where it's one thing, please note, is we need to open this in incognito mode. Yeah, so this is to make sure that we are using the test environment we created, right, and not getting charged for any other. Keeps it clean.
How do I open it in incognito?
You see this.
You have a Chrome browsers.
Right click on that open console. Yeah.
Right.
Yep.
Open.
Yep.
This is actually written for stats. Yeah.
Yeah. Make sure we are doing everything in incognito mode, please. That way. Yeah.
So I'll open incognito.
Yeah. Everybody at this step? Hit next, and then we'll have to copy the password from the old browser. Yeah. Yeah.
That little icon will exist in many different places as you go through the lab icon instructions. So there are places you may have to type. So you just do that copy. So we're trying to save you some time. Sometimes we just need to have a simple type error.
Yeah, this saves us time on the next, and it should be in. Yeah. Yes. Yeah, so good.
One of the important things on that original page, you don't say something project ID. You're going to want to check to ensure that this top one is the same project ID as what you have on that.
This here. Yep. By default, we should only have one project, and that should be the only one showing up. This is what Google Cloud Console is, right? And these are the different products that we have. Today we'll be working with products inside of this Vertex.
Go back to the the lab side of it. So I'm gonna show something very quick.
Sure.
So one thing you notice that each lab has allocated very specific time. It's a very reasonable time. For this lab, it's like hour and a half. Certain labs only hour. In the future, if you're doing all labs, I will always recommend that kind of read through the whole lab ahead of time. Even though that hour and a half is pretty generous, I've seen most people are finished actually way ahead of time. But there are people sometimes, you are multitasking to other things. I will say just, read through it and then before stop and we'll save you some time. That's one tips. The other thing is the clock is ticking. So which means that if we do weekends, we give another lab to do it on your own. If that lab is an hour and a half, you want to make sure you dedicate yourself an hour and a half to do that.
Yep.
If someone calling for lunch, come back, the clock is still ticking the last time until we restart it.
Yeah, you will lose everything. If the timer expires, we lose all the work we've done. Okay. Share this tab instead. Everyone in? I think from now we can. No, there is no lock. Yeah. Yeah, you lose all the work.
Someone could be following you when I come back and fitting fine. Why do they because it's an environment. So you can for use case you can
Yeah, it's resources. Yeah. Yeah. Let's search for agent builder in the search bar up top. This is where we are building our chatbot, our first chatbot, which will help us translate. It will ask you, hey, do you want to activate that API? So let's continue and activate the API. Is this visible? Let me make it bigger. Okay. Everyone see the screen? Agent builder, create an app. Fantastic. So we are going to click on this agent. Let's hit select. It will ask for this region. Let's give it a name. I think we are calling it, what are we calling it? We are calling it a translation agent, I believe. We are calling it a translation agent. Let's do that. Agree and create. Does for this one does not matter because you can pick a region you want to. Everybody should see this screen here, right? So what we are looking at here is agent. The goal of this agent is going to be, we wanted to build a translation chatbot, right? We put a phrase in a language and we tell it to translate to a different language. The chatbot should do the translation. We can give it instructions, including giving it a name or how to greet, how to end a chat. I'm just walking you through what we see. If you recall the diagram we shared in the slides, there is this concept of tools where you can give it some tools to help do certain tasks. And then on the right side, these are the different models that it has. In this case, there are 3 that you can pick and use to build your chatbot. Let's go back to the lab and pick the appropriate. Oh, the region it said was global. I made a mistake, folks. Let's delete this one and create a new chat. Okay. Go back. Create a new agent. I don't think so for this one. It does not make a difference. We are not giving it any. Go ahead, create an app. Select. Global, create. Let's go to the settings icon. Yeah. Let's go to task number 3, where we can enable conversation history and logging. So this is if we want to go back and debug something bad happened. So this is under the, if you go to the left side settings, enable logging, enable conversation history, hit save. Click back on agent, click on default generative agent. And now let us give it a goal. Everybody with me at task 4? Awesome. So here, the goal for our chatbot is going to be to translate from English to Spanish, French, or Chinese in this case. So 3 languages. Let's go. I'll share this tab. This is my default goal. And then these are the instructions. We make them bigger. Yeah, so this is where we are giving the chatbot instructions on what it needs to do, right? It needs to greet the user, and then it will inform. As we go through the chat, you will see how it follows these instructions. Okay. And let's hit save, and let's pick this pro version and let's give it a try. Hi. What language do you want me to translate to? I think the first example is Spanish. Okay. Spanish. Okay. Let's give it an example. It's a beautiful day in the neighborhood. There you go. Was everybody able to get it to work? That's it. As simple as that. And now we'll build it a little more will add to the complexity. So a neat thing about generative AI is if you give it more examples, and this is where we'll give it more examples, it will start to behave per the examples we are feeding it. And that is what we are going to do next, is we are going to give it samples on how to answer. So let's go and give it some examples. Let's hit create new. Let's give it an example name, calling it here. English to Spanish example translation. Everybody able to go to example screen? Nice. Okay. Add an action manually. So this is where we are giving it an example. When we say hi, it is supposed to say this, right? Hello, I am a GenAI powered translation bot, blah, blah, blah. We click on the plus sign. The user input is going to be Spanish. So that's it. All we are doing is we are building an example. So when we replay our conversation again, it will follow the example that we are giving it. And then when you're done, you can hit create and then it will save it on the left side. Click on it. Should bring up your own example. Go back to agent. If you, after saving, you can cancel out of it and then you will return to your original screen. See this circle here up top? This will allow you to reset the conversation. Then you can start from scratch. So now if you say hello, there you go. It now has an example to refer back to, and then it will follow the example that we just created. And now if we say Spanish, okay, let's go Spanish. Because in the example, we have specified it to go this way. Was everybody able to create an example and retest it? Nice. So yeah, we did it way faster. It's what, 20 minutes in? Very nice. But yeah, so this is our basic chatbot. Now we have time. Let me walk you through some of the other settings that you can play with. See here, conversation history, where we had gone and told it to start logging. These are the 2 conversations we had. Integrations, you can connect this to Slack. You can connect it to Twilio. There is a whole bunch of technologies you can connect it to, and then have your chat automatically translate from there. This is where you can specify which language model you want to do or use. There is this concept of token limits. So, right, if you remember, why are large languages model LLMs called LLMs? This is what makes them learn. Right, so how much data can you feed an LLM? Right, this is what we call as an input prompt, and then how much data can it output, right? So up to 1 million tokens. 1 token is approximately, think of it as 4 characters. So you can give it like an audio file plus a PDF, a small video, and then, hey, do something for me. So that is your input, and then you can set the output to again be of different lengths, right? And then temperature is how creative you want your large language model to be. When you say it to be 0, it will be very factual. When you make it all the way to 2, or whatever the max value is, the LLM becomes very creative. It will invent stuff. When we say hallucinations, this is when it is hallucinating at its highest temperature. And then there are safety filters if you want to block hate speech, right? All kinds of settings to play with. So yeah, like that's all I had, or we had. Any questions, team, friends? In this case, we built a translation model, right? You can, let's say you want to do that Supreme Court audio. you would need to feed that audio to this, and you can just change the instructions here. And instead of saying do the translation, you can say summarize the audio file for me. That's all you got to do. There is no complicated programming or anything involved. You just have to give it English-like instructions, and the chatbot will do what you want to do. Anything else? Any questions? Comments, concerns? Examples? Yeah, we got to do some examples. So for example, we are building a chatbot to help San Diego City municipality codes, right? There is a whole bunch of 450 PDF documents with a lot of municipal codes in it. Now we have citizens wanting to know, hey, what building code do I need to search for? So you build a chatbot, and what you do, one second, let me show you. So you've given it example. In this case, the instructions are, hey, you are a helpful, San Diego City municipal agent. And then here you specified the data store, which has all the codes in it, the PDF document. And then a citizen comes in and searches, hey, I want to build a bathroom with this specs. What are the codes that are applicable for me? The agent, the chatbot goes and searches the data store, and then it says, hey, these are the guidelines you have to follow, for example. So yeah, in this case, it was just all PDFs, but there are use cases where, or examples where there are inmates, right, who are making calls, and then the lawyers want to make sure that they are not discussing something that they should not be. So we have these audio recordings, right, video recordings. That can be your input. And then the lawyer comes in and says, hey, for this person over the last month, have they said anything that has broken the law, right? So this chatbot then goes and searches those audio recordings, and you can also specify, give me the timestamp and the date, right, when this was broken. So your imagination is the limit here, right, of what you can do. But these are some of the use cases where you can use them. Is that making sense? So this happens to be a very simple one, right? Translating from one language to another, but the use cases can be complicated. Yes. Can you use this to make spam calls? Not. Yes, this can do text, not this particular one, but yes, you can build something that does text to voice. Yes. That's also fairly straightforward. Yes. So in that case, what you would need is you specify what you want the message to be, and then you also give it a bunch of phone numbers, right? You want that to be programmatic. One after the other, it will start calling. You will lose a bunch of friends, but you can accomplish this. Yeah, you can create a spam caller. Yeah, one neat example I saw in the commercial side was, you draw these diagrams, architecture diagrams, software diagrams, right, on the board. You take a picture of that, and then you feed it, and then it goes and it actually creates the software behind the scenes. Yes, just from a diagram. Well, from a diagram, and then if you like, it was a database diagram, you specify the columns and rows. Yes, you can do that. The other more common use case is, folks know SQL here. So SQL is the language used to talk to databases. So you can talk in this language. This can translate into SQL and query the database. This is actually very popular. Not only that, it can also draw fancy charts and graphs. So yeah. you can let your imagination run wild here. You saw the images that we generated, right? For the robot with detention. Firstly, it generated the joke. I told it, hey, I'll show you 1 second. Let me just full disclosure. So this is an example. Yesterday I was working at it. Share this tab. Okay. I need to give a seminar. Da-da-da. Suggest a couple of good jokes. And then there is another tab where I am actually here. Okay, see, it actually misspelled detention both times, by the way. So here is an example where I said, hey, why did AI get detention? That's the joke, right? It kept plagiarizing internet. Generate a cartoon image. You can see it misspelled both detention and plagiarism. Now I'm noticing it. So, okay, generated an image. Give the above image in a classroom setting. So there you go, right? I actually had this one too. What's the difference between you can explain to a teenager they are wrong and then this generated this image. So anyway, so an example of, oh, I'm not sharing those. 1 second. I wanted to share this. Yeah. Here. Generate a cartoon image for above. There you go. So yeah. This is that. So we saw the use cases, right? Create. This is the create aspect of generative AI. The other one we were doing was discover. Actually, it was create. But yeah, search and this one is the more common ones. But yeah, thank you for your time. Have pizza. If you have any questions, we are here. Sure, sure. Mhm. Or less energy intensive. So, okay. Training these models, if you train them on GPUs, you're right, it takes a lot of energy to train these models. And why does it take that much? Or why are GPUs good at it is it does matrix math. Okay. So it's a lot of matrix multiplication. So small number of calculations, a lot of them done in parallel. GPUs happen to be good at it, but GPUs are power hungry. Google has a version of it called TPUs, tensor processing units. Tensor is a matrix, but it's a little more power efficient. So if you want to study something where you can use to make it make this more power efficient, I would study like electrical engineering and specifically how do you do this matrix math efficiently, faster in parallel. CPUs are bad at it. CPUs do one at a time. GPUs do multiple in parallel, but they consume a lot of power. So that would be, you need to understand the algorithm, what is happening behind the scenes in the algorithm. Most of it is matrix multiplication, and then something to help translate that into hardware.
So we're one of, I think we're the first company that actually has 100%.
Right.
So there's ways to kind of, yes, it needs to be, unfortunately.
Power hungry. Yeah. Yeah.
Have a whole sustainable section for what focuses on how to make it more efficient, how to make it not wasting so much.
Yeah. Yeah, that's the other option, right? You generate more power using solar, for example. We used to feed GPUs. Yeah, sure. I am not. Oh, Jen, do you know of the cyber? Yeah. No, separate labs. Yeah. 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 Yeah.
Not just from the business side of cheaper, but as well from the environment.
Sustainability side of things. Yeah. You would also see certain regions which will have a green leaf next to it, which tells you that these are more energy efficient regions where you can put your data center. So that way you are also minimizing your footprint, carbon footprint. Yeah. Yep. Yep.
So what you'll find a lot of our competitors and vendors is they have it one. Ours do everything on a platform. So whether you want to do this here or you do this here, specific, or even over all you can ensure that the environment is stable without you having to select only specific.
Right. Gemma would be our equivalent. Yeah. Offline, not the ones I showed here because it needs to go and get from the mothership. But if your device is able to support it, then we have an open sourced version of models called Gemma, which is like Llama. You can use that for.
But I think like have it as well because we do have some federal customers, and I could imagine that those similar systems. I think what you're
Isolated, not talking to internet. Yeah. Yeah. So, yeah. Play with it. Yeah. Yeah. Yeah, but yeah, to put like controls on it, I would say reach out to us so that you don't get like a surprise bill, right? That's the last thing you want. Yes. GPU, yeah, it will be churning like, yeah.
But I think we have a lot of those conversation with our university. I just had one recently with UCLA. You know, the idea which is really there's quite a bit demand for using just cloud consumption in general, right? Whether it's for education, whether it's for research labs, whether it's for just the community around that. The idea which, sometimes there are some of those practice, what we do is we can sometimes allocate a set of the resources, whether it's GPU, CPU, like the large things are really for faculties, for researchers, like the large models, like when genetic, genomic models with quite a bit of things, but typically it's pretty hard. In the past, you had to kind of buy a lot of hardware, run your own things, but that still kind of limit the scalability. Sometimes schools out, nobody's winning any, like everybody's out, but then you come back in school, all of a sudden you might run this large research lab that will require thousands of CPU or GPU chips that run the model only just for like a week, right? So those are pre-allocated. But then on the student side, same thing, right? Because ideally it would be easier for every student who want to have some kind of lab or environment for their own, right? A virtual environment that's for the student that can just onboard in their own tenancy environment for your own classroom setting. So there are a lot of practice that we're seeing from Stanford for some of the UC system that I'm familiar with. We have those arrangements. Yeah.
Yeah. Yeah, yeah. Yeah, you can upload, you can actually have a video recording of the classroom and you can ask it to create a PowerPoint presentation for it. Vice versa, you can feed it a PowerPoint presentation and hey, create a lecture for me on this. Yes. Hmm. Yes, you can ask these questions. In this one, we are actually typing or chatting for it, but you can even like talk to it and then you can get your question answered from that audio recording in an audio format. Yeah.
All of these large language models, they do not perform nearly as well as the enterprise. So just keep that in mind that like you might just go to the baseline, most simplistic one, and it might not necessarily have a good response the way that you want it to. But then the enterprise grade really is where the show is.
Yeah. Pick the right model for accomplishing your task. Yeah.
So the things they're talking about, we'll actually have a lot of conversation with the university and school there.
Yeah.
Because technically that's all possible. It's just someone needs to kind of put all those together, right? Because I look at from GenAI perspective, the outcome one is really, from all the data sources, right? Whether it's a recording from classroom settings or remotely or professors talking, we can recall like a lot of things, like textbooks and all that. There's a lot of thinking about how do we consolidate all those information. This is sometimes we will probably spend the next thing to do is that what are the popular languages like for students now? We're so busy, our attention are so short. I don't want like get assigned for the professor asks me to read this 5 chapters over, but I'll be nice to like I have all the past lectures and all that. Make a podcast for me. Right.
Right.
5 minutes podcast. I have that 20-minute podcast. So I can like go to gym in the morning. I'm jogging. I'm listening. Right. So that's definitely a way of learning with the new GenAI capability that's in there. But you can take all those multi-model, different kind of video, whether it's recordings, classroom recording, whether it's from the textbook, whether it's those pictures, student draw, like in the classroom notes, right? All those things can be extracted, summarized, and then you want to reformat this in the way that you want it so you can run this.
Yeah.
I want to remember.
No, this is why we are here. Yeah. 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 This one doesn't judge the chatbot. You can keep asking. There is, yeah, that's really, yeah.
So, because I had that too. detrimental for my mental health at a certain point where I can't even ask questions, it's not safe for them. So just one thing I would urge you for that is don't let them deter you from asking questions and being curious, because that's really important for your growth. So just
Yeah.
that. And one other thing I'm gonna say, when you use the free version of the large language models, that information is gonna be used to train the model. So just make sure you're not giving sensitive information.
Yes. Yeah, asking math questions is totally fine, but yeah, keep that in mind. Yeah. Paid version, enterprise version. Yeah, go ahead.
Everything on Google Cloud is you're paying for it, literally you own.
Correct.
Even our support staff, if you reach out and say, hey, this is broken, we can't go into your instance. You have to explicitly tell us, I want you to go into it, I give you permission. Has to be the case. So,
Yeah.
no, none of the stuff that is paid for on there is utilized to train anything. It's
Correct. Your data.
federal agencies, health agencies. That's one thing that we're really strict about. You own your data.
Yeah, your data is your data. We've never see, never access, nothing. You make a call, the response you get is only you see it. That's it.
Even if you build out a large language model and fine tune it, that
Yeah.
version,
Yours.
get a base frozen version that it builds on top. So,
Yep. Yeah, we are very strict about that. So that's, yeah.
There's another question.
Yeah.
Since the UH is Google based.
Mhm.
Is GenAI?
Yeah. Oh, yes. So this is where, I mean, I can answer, you can add, please. So the way our product direction is going is generative AI is being infused in pretty much all our products. So Workspace is a good example, right? Where emails, whether it's summary, search, all of that. Yes, you will see more and more generative AI features incorporated in our product. So Workspace being one of them, our database portfolio, all our databases have this concept of vector search, which is unique to generative AI. Our data warehousing, machine learning, all our products are getting that. Yes, short answer. Ah. Ah. Hmm.
UH department could technically buy those languages.
Yeah. Yes.
That's just like Gemini for Workspace.
Yeah. And by the way, so I have access to this. So large documents, it's easy for me to summarize. Like we take these long meeting minutes, right? It was like an hour-long meeting, 5-page worth of typing I've done. Okay, dude, summarize this me for in 5 to 6 bullets. Makes it more digestible. It's really helpful, this generative aspect of it. Yeah.
On the website, which is still on.
Yeah.
And I know that Google offers websites, right?
Yeah.
So, I just don't understand why the university is not incorporated.
Yeah, I mean, and to your point, there are like the websites have grown so much. There are sections of website that are probably obsolete, right? Have bad information, wrong information, right? You want to scrub these. So yeah, this can be an excellent use case, right? And like our search, for example, crawls through all these websites. It's a similar technology we are using, right? To then be able to, okay, you specify it and you can search across it. Yeah.
Website, and then manually have to go.
Oh boy. No, this is the right use case for it. Yeah.
Yeah, we can help out.
We can, yeah, that is it. Yeah.
Those are the things actually. It's pretty easy to do. This is one of the Google's.
Yeah. It actually works on our cell phones. I mean, I have Pixel, but Google Photos, you can search by a person name, right? And you get that person name. Yeah. Yeah. And we are always here. Like if you don't think of something, reach out to us, right? We love like passion of ours. Yeah.
There'll be a follow-up email with the contact information.
Yes, we can send. I created an alias after Daniel taught me. It's the AI guy at Google.
Oh, the AI guy?
Yeah, I took that. I took that. Yeah, no, but we'll share it. We'll share it. Yeah.
I haven't come up with a smart acronym, so no, I haven't thought.
Yeah, I
Mine's-
have one for you. I love Ayazi.
Oh, I love it. I'll take that. I have another.
Sure, sure.
So I've used, AI.
Yeah.
Never had it, hallucinate quite as bad as, I had like a really simple, like, toy intelligence problem. It was like, Rails cyber or something.
Mm.
And it just like started like outputting gibberish. And do you know why?
Oh boy, yeah.
We have to look at your
Yeah.
prompt to see. There's a prompt engineering, which is basically learning how to properly
Create a
CMC language, by the way. I would say that's where we have to start. But no, there's some weird things that happen in certain places, and it just really needs to be studied and but
and I think some models are bad at math also. Like there is it's so cryptology will fall under, I would think, in math. But yeah, we will have to study the prompt.
so like large language models, there's some that are what we call multimodal. They can take everything from images to text to audio.
Mhm.
And then there's ones that we've like developed to be really particularly
Task specific.
So like for example, we have like a medical one that's been trained on medical data specifically. They're probably similar ones, but not maybe like cryptography, but I would hope between prompt engineering and using one that's probably good for better response and stuff, not gibberish.
Yep, and yeah. No, but the other point to that one is there is techniques. There one of them is called RAG, where you pass it examples, right? It's again style type of prompt engineering where, hey, you give it an example of a successful decryption or encryption that work or is the right example, and then you ask it, hey, what about this one, and see if it solves that way. That would be one example. The other one is you can specify it a set of, I don't know if there is books or class lectures which are targeting that, and tell it that, hey, use this data to solve my problem, right? You can be explicit about it. Those would be the two ways I can think of, absent like creating a targeted model to tackle your problem.
How will quantum computers change
This
AI?
do not know. That's I used to work for Intel before Google. Yeah, and I honestly, quantum computing is yeah, it's hard. It's probabilistic computing. It's a whole new layer. I'm not I'm not well equipped to answer that one.
Very soon, but
Will it? Hopefully.
that's the question.
If we've learned anything from AI, which I'm not sure if you all know a little bit, you went through the history or no, sorry?
Yeah, the winters.
Yeah, so AI has been around for quite some time. I'm sure there's some uses of quantum computing that we just are not aware of.
As of today, yeah.
But how it's going to change it? Maybe that's the next generation after AI.
Yeah. Yeah, I told them my example. When I was doing my master's in 2000, I had to do it on paper. A 3-layer deep neural network is as deep as it goes. Then you have to hand calculate back propagation and all.
So here's my thoughts in general on the physics. If you look at the big challenges with the AI general, AI will have four things. One is a model, right? How good a model, how sophisticated, how smart the model is. The second is what the amount of data is so much to that, right? And the third is really about computing power. Yes, the amount of computing power that we have today, like even back probably back to
10 years ago, we didn't have it.
20 13, one Jackie was the one about like AI, tools like Google. At the time, was talking about well, back then because they would have all those Google devices like phones, we were trying to analyze those things. If everyone's recording 3 minutes of recording, at that time that was like a decade ago, we basically exhaust every single CPU on right. But now it becomes an AI revolution, right? Now all of a sudden GPU is helpful, it's 10, 20, 30 times faster than typical CPU. But the amount of data we need to train is humongous, right? So that race there, we can make the model better, we can make the chip faster, but we'll never get back to where we can man out the data, right? So we'll still kind of go back to the basics of how can we make the chip more condensed in a way that we can make it go faster and faster, working very hard at speed. I think this concept can come in about certain things. The second thing is the way how data stored on the storage side, right? The speed of, let's think about this. All those data sets have to save somewhere, right? What's the way of storing this data? The majority of the data stored on the disk. Is our disk technology that can come up? No, it's still that 70 billion, 50 billion. With a lot of disk spinners, yes, we have a fraction clock and that has really faster. Reading those data out, right? Petabytes of data, how long does it retrieve? We're training those data forever. So how can you do the fast way to condense those data to web absorbing data and then fast retrieving those data sets up, right? And the third is the transformation, the transfer of those data from a network perspective, right? From storage to the CPU or GPU side up to speed of training, right? With better modeling. So I think what concrete really comes into really condense the storage models to speed up that network transfer, and then also with the model, continue to make the microchip smaller, but faster, but there's still a process.
I would envision right in the future, the data center is almost universal. Every country is contribute the cost of building the universal usage and put them up in space when it's so cold.
Oh, that's a good point.
Yes. And then, because I'm reading that pretty soon you can use light to transfer data and store data.
Yes, but this is really in the speed of light, right? This is really coming. This is really what that transformation.
But even light still needs cables. So that's the hard part.
Oh, we have AI to help.
That's true. That's true.
This whole comments.
Any other questions?
Just 3 years ago, there was no such thing as generative AI. Like, think about it, right? All these use cases, like these chatbots and all that we are building, it was just a research paper. And the research paper was titled, "All I Need Is Attention." Yeah. That is the T in GPT is transformer, is the Google research paper based. Right? Just 3 years ago. Thank you very much. Yeah. Yeah. Yeah, there is something right.
No, hackathon is a great thing to have. So we have 2 challenges and keep an eye on those ones. And it's great to participate, without some of the challenges and the trick type as well.
Yeah. You can hack it with it.
It's just developing those relationships that on one base. During the hackathon, that will serve you. Actually,